And I'm going to show a couple of example scripts that we have that use the framework to look for key events among terabytes of data to pull out points of interest. And then I'm going to show some custom functions that I've made in Python based on requests from our customer Ford. And then one of our customers, Marty Farrell here, is going to come up and talk about some of the applications of this framework to his own data. Oh, right, yeah. So this first slide shows our data analysis plotting tool that we call DataSpy. And it's mainly just a plotting tool where you can plot signal data. And in this view, there's 3 stat graphs that all share the same time axis. And so you can put a lot of different signals on that screen, and you can make sense of all of them, and at the same time, and you can share put them on a common y-axis, so you can really have a lot of signals on the screen to understand complex events. And a real common use case in DataSpy is for someone to put a time cursor, in the plot, and then look at the legend and see, what's the value of all these signals at the time cursor, and then they'll step through and debug, what's going on in your data. And so we packaged that concept into a library that we call IPA. So the whole idea of having a virtual time cursor in the file and then having an array that lists what are the scaled values of certain key signals at that point in the file. So that's what this library is based on. So there's functions in it that you can open a data file and you can load in the signals that you care about, and then you can move the cursor around in the file, and then you can look at what's in the array and do analysis on that. And we have a bunch of example scripts that will make histograms, or they'll pull out signal statistics from key signals throughout a bunch of files. And the cool thing about it is we've also compiled this library as a shared object that we have running on our cloud-based server. So you can develop scripts on your PC to make sure that they're doing what you want, what your analysis to do. And then you can upload the script to the server and have the server run the script on terabytes of data that are on the server without having to download any of the data. So you can make your own data mining scripts. And in addition to the script, all the scripts have a config file that tailor the script for a given application. So like if your script makes histograms, then the config file would list the signals that you want histograms on and what their bins are, and but we have, a lot more complicated scripts that are, more powerful than just histograms. So one of the scripts that's really popular is called Find in Files, and it's named that if you ever used an IDE for coding, and you want to search for a string among a bunch of code files, they call it Find in Files, where you put your string in there, and then it gives you a list of all the hits in your code base where it found the string. So that's the reason it's called Find in Files. And so this at the bottom is an excerpt from the config file of the Find in Files script, where you can define a list of events that you're looking for. And so each event has a description, like the first one here is watt launch from rest. And then there's a start expression and an end expression. And these expressions are just Boolean expressions of the signal names in the file. And but you can also use any Python commands or functions. So like the and the brackets and any operators that are supported by Python, you can use in your expressions. And then when you run the Find in Files, it will, you run on a list of files, and it'll look for the start expression event, for all the start expression events on your data. And then if it finds the start expression to be true, then it'll start looking for the end expression. And then it finds the end, it says, here's a hit, and then it'll log that as a hit to say, I found this watt launch from rest event in this file. It started at this time and ended at that time. And then in our DataSpy plotting tool, you can open up that hit file, and you can see all the hits and step through them just like you would in your IDE. And so inside the Find in Files script, use this function called eval, which is a common function among interpreted languages. Eval allows you to evaluate a string at runtime like it was a line of code. And so the way the final files works is I take the start expression and I reformat it so that it's executable at runtime. Like I replace all the signal names with their index in the scaled array, so that then I call eval on that string and it returns the result. So the reason I did it that way is it allows you to make your own functions in Python, and those functions will work in your expressions. So you might have one or two people on your team that might be familiar with Python, and they can become familiar with the library, and they can make more custom expressions, and a much wider audience can describe events in the start and end expression than could write their own code. So you can have these custom functions, and so two of the custom functions that are included with the IPA library are time while true and time since true. And the time while true takes three arguments: an expression, a min true time, and a max true time. And this is used if you want to say, I want to find out when expression one is true for a minimum of some period of time. Like say the catalyst temperature is over 950 degrees C for more than 50 seconds. You can put the catalyst temp in expression one, and then the min true time would be 50 seconds. And then if it's ever true for more than 50 seconds, that'll register a hit, as opposed to just the catalyst temp is over 950. And so that's an example of one of the custom functions that we developed. And the max true time is like a timeout, like, after some period of time, then disarm it for the next hit, if you wanted to return false, after some period of time. And then time since true is similar to time while true, but it only looks at the toggle of the state in expression one. So like if you want to look for an event that happened within 30 seconds after an engine start, you might describe the engine start in expression one, and then have your min time be 0, and your second time be 50, and then that would be true 50 seconds after the start. So then you could and that with other conditions to say, my fuel air was richer than 0.06 or something, so you could find when the fuel air went rich, following a cool start. So just kind of an example of these couple of custom expressions. So the code that does the mining through the file here in this part, the mouse is better, but that's written in C++. It's written for speed. It's written so that it can go through terabytes of data, I think it's like a gigabyte a minute is the rate at which it'll process data. And these other functions are written in Python, so that you don't have to mess with the library in order to customize it. So Ford is a customer of this tool set, and they use it to look for events that Marty will talk about later. But Marty came to me and he said, we want to identify events on our proving grounds based on their GPS coordinates. So like the drivers run through these cycles, through the various events on their proving grounds, and they want to be able to identify those events and then do some analysis on the vehicle data while they are on those events. So I made this custom function called check for geo event that it takes three arguments: latitude, longitude, and then this third parameter that indicates whether you want it to return the index of the event or the name of the event. So like there might be an event there called the rumble strip track, so you could either say, I want to check if my current latitude and longitude are in the rumble strip track, or these events also have an index. So you could just say, if it's between index 6 and 10, then tell me that it's on one of these events. So and there's two methods that this function supports for describing your events. One of them I call the box method, where you define 4 GPS coordinate points, and then if your current latitude and longitude are inside the box made by those points, then it'll register, hey, I hit on this particular geographic event. And so you could draw a big box around the garage or something, and then you could say, okay, the vehicle's in the garage now because it entered, this big box. And then this other method I call the line cross method. You just give it 2 GPS points, and then when your actual logger GPS points cross the line that's made by those 2 points, then that will register a hit that, hey, you crossed this line. So it's kind of like a virtual gate where you could draw a line across some track on the grounds, and then when your GPS points cross that line, it would say, well, when they cross the start and then the end, it would say, okay, I registered the hit. So this is an example of the config file for the events. The window on the upper left, it has the 4 points, and well, you can see the name and the index. The index is 6 for this one, and then there's 4 points: the northeast corner, northwest corner, southwest and southeast corner. So on the left is for the box method, and then on the right there's only 2 points per event: the geo event 1 and geo event point 2. And that's the one for the line cross method. So you can have unlimited number of these events, and then you can search through all your data, and then it'll find those events and organize them in hits, and you can step through them all, to find data on a certain track. And then, so down here is an example of an event that uses this function. So the start expression is check for geo event equals 8, and the end is check for geo event equals 9. So that would be these 2 points, cross track start line and cross track end. So those are event in the index 8 and 9. So that's what this, I call it rumble strip track. So if you get a hit on the rumble strip track, that's when it, entered and exited the rumble strip track. And then we also added this other key for the events that we call event-based metrics, where you could say, when you find data that's on the event, I want you to run these calculations, so like there's a histogram on attribute 1, and we hold our customers' data, very, very, it's very private, and so we don't share it in a public setting like this. So we're not using the real names of the signals, but attribute 1, it could be high voltage battery voltage, or pedal, or whatever, some engine speed, or but so you could say, I want you to make a histogram of this signal, and then here are the bins for the histogram. And then there's also min, max, average, value at start, value at end. So this is just saying, hey, when you find this event, calculate these statistics or these metrics on the event, and then tabulate them for review, at the end. And so I only recently made this function for Ford and showed it to them, and they're building their events and are going to be, doing characterization of their vehicle's functions on the track. So that's the end of my presentation about this particular part. Is there any questions about the what I've shown so far? Okay, so I'll invite Marty to come here and talk about the applications on these tools.
Okay, so at Ford, we've been using the wireless nearby data and the data spy for several years now. It's been very valuable to us. We have ions that we put in every vehicle that runs around our track. I don't collect every single signal on the vehicle. I do that in the background, as I can do a manual upload. But on average, I'm collecting 3,000 to 4,000 signals 24/7 as it runs around the track and all the different events. So it's a huge data set that we can use at the end for looking at different issues we find, or development and research issues. Back, I don't know, a few years ago, I was talking to John. Data Spy has been working great, but we wanted to do a little more complex signals and data mining, and he was already working on the IPA scripting. So we've started using that quite a bit. And then just recently, I had an engineer that contacted me that was looking at a vehicle that we ran a few months ago. And him and a coworker was kind of suspecting that a certain condition could have happened when it was running. And one of the attributes was a state encoded, several different state encoding levels. He was only interested in 2 of the state encodings. They had to be in one or the other conditions. And then another attribute had to be within a certain parameter. The third parameter was several different signals that was calculated on an algorithm that had to fit within another window. And he said, is there any way, this is just all theory right now, is there any way that you can, data mine over the time of the test and see if you can confirm if that really happened? So he gave me all the parameters. I made the JSON file, config file. We ran it. It was 2,000 files. It was over 2 months of data, 24/7 running, and ended up not only finding the needle in the haystack, we found 7 hits. Ended up in about 28 seconds out of over 5 million seconds of data that we collected. So it's kind of priceless. So now it turned his theory into actual reality and had data to back it up. So now they can take that back and change things or develop it even more. Another example, I had another guy just recently ask me over the life of the test that the vehicle that he was looking at, he had 4 different kind of attributes that he was looking at, whether it's speed or battery voltage or whatever the case is. He wanted to know a histogram of those 4 different conditions, how much it spent in the different bins. So he gave me the different channels. He gave me the parameters he needed, the bins he wanted. I made the file, and that one was 2,206 files. That was about 2.5 months worth of data of 24/7 around the clock running. And when it spit it out, that gave me these 4 graphs, and he was able to go back and he knew, what those different attributes were and how much of the life of the test at that time was in those different bins. Again, that's kind of priceless information for him. It kind of took theory into actual data-driven decisions. Then most recently, what John was talking about is the event space matrix. We do these on several vehicles for months at a time, and at the end, we give a test report to the different attributes within the company. This is the test. This is what we did. This is how the data that came out. We want to have a little more data driven. So what we're starting to do now is geofence all our different events, the several different events on the proving grounds. And we're going to have different kind of attributes, whether it's speed, how closely we basically ran the procedure. We have real critical procedures of how we run the test. So we're going to, basically at the end, when all this is done, with the files that he did, with the config that he did, be able to give a report at the end of how well we ran that procedure. So how many times we ran the rumble strip, or how many times we ran this event or that event, and how close we were to whatever the procedure was for that. Was it a temperature driven event? Was it a speed event? And then give that report to them, and then that can go in the logs also for better decisions making at the end. So this is one of the examples here. So that is actually on our proving ground that I won't get fired for. You can go to Google and be able to find that out. But this is the start location of the event, and this is the end location of the event with that blue cursor there. And John was able to write a Python config file that was able to make that as a starting place and the end place on it, ran a bunch of data, and was able to come back and tell us how many times we ran through that event. And then we gave them certain things to look for in that event, and they spit that out also. So when you start thinking about that kind of thing over the life of 2.5, 3 months, it kind of becomes priceless for you. The possibilities are kind of endless. It's just a matter of how much you can think to do with it. This area here, this is the report of the event space matrix. You can quickly start going through there, and you can summarize, like this line up here has 0, 0, 0, and then 3. So it was supposed to be at 0 for the whole time, and then they hit 1 here. So, you can start seeing trends that way also. It makes it a whole lot easier to go back and look at 3 months of data. So that's the view that I have.
So I got a couple, these presentations are going to be, posted. And I got some YouTube videos that talk about Data Spy and IPA and more detail as opposed to this focus on the final files. And we also have a demo out in the lobby there if you wanted to see more about it. And I'm John Mitchell, my phone number there if you want to contact me. Please do.